In this video, I'm going to show you how to change radical expression to rational exponent. What is radical expression? Anything that is under radical. Let's say square root uh, 81, right? That's radical expression, square root x to power 3. Radical expression, right? Everything that has radical. Now, what's the difference between radical and square root? Radical is any degree but 2. So it can be 3, radical can be degree 4, radical can be degree 5, and so forth. The square root, because it's very popular, square root, so that's why mathematicians gave a name to it, square root. So you will know it's 2 here. Every time when there is no degree, that means it's 2. And when by default, we don't even put that 2, right? Therefore, when we are talking about square root, we understand degree 2. If it's more than 2, then we are writing down the degree. All right? What does that mean? Now, this degree. If I have cubic radical, so degree 3, x of power 3, that means I have to have 3 of them of the same base. So 1 will come out. Do I have here 3? Yes. So that means I can break down here x times x times x. Yeah, and indeed, we have 3 of them, and 1x will come out. If I have cubic radical of x squared, so I have only 2. That means, but I need 3. So I cannot take anything out. It's going to get stuck. And what if I have more? Let's say this time I put 4. But I have here degree 6. So 4, I have 4, I have here 6, right? 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So out of this 4, because we need 4 here, 1x will come out, right? But these other 2 will not come out. They will get stuck under radical 4 because they don't have enough. They have only 2. You understand? That's what it is. Now let's go back to our solve our problem. Evaluate if possible. Let's see. How much will be square root negative 121? One thing I can tell you, because it's a square, degree 2, that opposite operation, square root 2, let's say square root 9, we need to find the number, the square of which will give you 9, right? So that will be 3 squared, correct? Now, if I take, let me give you another example. If I put square root of 16, it's going to be equal 4, right? Because 4 to power 2 will give you, let me take this, the 3, I can write down this way, 3 to power 2 is equal 9. So this is this 9. So I get 4, because 4 to power this 2, I get 16. Now let's take negative sign, negative 3 to power 2. So that equal negative 3 times negative 3, right? And still I'm getting positive 9. Same way here, negative 4 times negative 4, 2 of them, because I have 2. So I multiply 2 of them. So I still get positive 16. What does that mean? If I have square root, there is no way in the world I can get negative number from, it can work with negative number, because I used positive number, I used negative number, and I still got a positive answer. Therefore, we cannot have negative number under square root. Well, we can get complex number, but not a real number. Complex number is a different story. We are talking about real number. It's asking about real number, so which means the square root is not a real number. Okay? So we cannot take out. There's no solution to this one. Next one. Number 2. Question number 2. Let me write down question number 1. Next, radical degree 5, see it's not 2, I'm calling radical. If it would be 2, I would call square root out of 8. Now, how we are going to convert this to represent in the format of rational exponents? Okay, this is the formula. Square root n a to power m, that is equal a is m come on the top as a numerator, n come to the bottom. So what do we have here? Radical degree 5 of 8. So my m is 1 right here, right? And n is 5. So my answer will be 8 to power 1 over 5. That's all. This is a rational exponent, right? Because it's fraction. Rational meaning fraction. Okay. Next one. Radical 9 of x to power 5. Again, m, n. My m is 5, n is 9. And I will get x to power 5 over 9. Next one. Square root. It's a radical, degree 8. And I have 5y. Okay. So what we are going to have, because we have 5y, this 5y I am going to treat like one term. Okay, so our m is degree 1, right? N is degree 8. So when we say degree, the m is degree 1, I don't mean only 5 y, 5 also. So I'm going to put this in parentheses, so you will see. And put here 1. Therefore, 5y in parentheses to power 1 over 8. Okay? Next one. We have radical of 7, degree 7, a plus b squared. All right, let's see. How much is my m here? What do you think? How much is my m? Well, I hear you are saying 2, and that is correct. Here it is. Right? We have degree 2. We always, till now, we would put 5, 1, because there was no any degree. Only here we had, in this case we had here 5, degree 5, that was for m, and we put 5 over 9. All right, so we have m is equal 2 and n is equal 7. So the answer is going to be a plus b n to power 2 over 7. Okay, let me move a little tiny bit. Okay, and all right. Next question. All right, let's see how we're gonna do this one. going to be radical 6 4b, and all this to power 5. Okay. When you have all these, the whole radical in parentheses and power 5, that is same thing if I write down radical 6 4b to power 5. I have no clue why they put this radical into parentheses and put 5, because it makes no sense. Because it's the same thing as a 4b to power 5. So I'm rewriting this way. And from here, it's easy to do. We are going to have m n. So m is equal 5, n is equal 6, right? So this is going to be equal 4b to power 5 over 6. Okay? Next one. All right, let's see what we can do here. We have number 7, radical 8, 14 to power 8. Look, what a miracle. We have 8 here, we have 8 here. That means 14 can come out, right? There we go. What conclusion we can draw? Oh, and here also I explained, right? You have to have the same amount, right? Free and free. So 1x will come out. So from here, you can draw a conclusion. If the degree under the radical and degree of the radical is the same, then that number or the clean coming out. All right? Next. Let's see what we are going to get here. We have radical degree free, or we call cubic radical, and then a to power 9 and b to power 18. Since we have here two different variables, a and b, we have two different variables, a and b. So they have, let me change, I'm saying different and using the same color. Okay, two different ones, and they have nothing to do with each other. Therefore, I'm not mixing their degrees also. At this point, I'm going to get a to power 9 over 3, b to power 18 over 3. Right? So, let me put this way. For a, so m and n. For b, m and n. So, what do we have? For a, m is 9, n is 3. For b, a is 18, m is 18, and n is 3. Well, we have 9 over 3, so which means we can simplify a to power 3. And b, 18 over 3 will be b to power 6. Simple as that. Next question. Let's see what we have here. So, question number 9. That is square root, in this time, 196 x to power 6 and y to power 28. Okay, square root So how much is square root of 196? I believe it's going to be either 14 or 16. Let me see. 14. So square root of 196, you can write down it's a 1 over 2, but it doesn't matter. So square root of 196 is 14. X is going to be 6 over 2. Y is going to be 28 over 2. I could write down, instead of 14, I could write down, go slow, write down 196 to power 1 over 2, because 196 has degree 1 here, right? Let me use red color so you can see. 1 and then 2. As you can see, n everywhere is 2 because we have square root. But 1/2, that always means square root. And square root of 196 is 14, right? 14. So 6 divided by 2 is 3. 28 divided by 2 is 14. So the shortcut is going to be, you are taking separate, if it's number, you are taking separate square root of 196. Then you have here 6, you divide by these 2 here. And then you take 28, you divide by these 2 again here. And that's it. So not to go through all this trouble here. That's a shortcut. Let me write down another one, a similar one. Let's say we have, I'm going to teach you how to do without writing rational exponents when you don't need to, when it's easily dividable. So let's say we have 100. And we have a to power 10, and we have b to power 14, and we have c to power, how much? Let me see, 12. So square root of 100 is 10. We have 10 here. 10 divided by these 2 is 5. B, 14 divided by these 2 is 7. And C, 12 divided by these 2 is 6. But if I add here, let's say D, and put here 7, 7 is stuck. So I will write down D 7 over 2. That one I will put this way. I want you to be crystal clear on this. Okay. So before show shortcut, I wanted you to understand where from all this coming. And we don't get every time this lucky and easily dividing. Next one. This is 9 going to 10. Cubic radical 64, a to power 18, and b to power 15. Very good. Numbers are talking, communicating to each other. 64. Whoever doesn't know, you can punch on calculator, but 64, it's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Where from I know that fast? If you would do as much math as I have done in my life, you would also know. I just know. It's not like I am specially talented or something. It's just practice, that's all. I used it so many times, so I already know. You can use your calculator if you want to, or you can try figure it out, that's all. So it's going to come out 4. Now A, we have 18 by 3. It's going to be a to power 6. That's why I said we are lucky here. 15 divided by 3, it's going to be b to power 5. Okay? Next. (11). It's a square root. Well, it's very similar to what we have, but it's never hurt to repeat. X to power 16 and y to power 8. Okay, try to figure out right away how much it's going to be. Very easy. Square root 196 is 14. 16 divided by 2 is 8. 8 divided by these 2 is 4. Okay, x to power 8, sorry. Okay, are we good? I hope so. Number 12. Now we are going to go backwards now. Given rational exponent 5x plus 4 to power 4 over 5. Now in this case we are given rational exponent, we are going to go backwards. Okay, so we know that square root, let me write down the formula, square root, here is n, here is m, is equal a to power m over n. So now we are going to go backwards here. So which means a to power m over n is equal, n comes here and m comes under radical. Well, let's use it. So my m is 4. Oops. And my n is 5. Which means this is going to be equal if my n is 5, it's coming right here, and m will come underneath. As easy as it can be. Okay? One more. Negative y to power 5 over 7. So my m is, let me see, my m and my n. My m is equal, how much? 5. And n is equal 7. From here, what we are getting? Negative y comes underneath. My m is here. I put to power 5. And n comes here, 7. Or you can also write down the way it's usually giving in the textbook. So it's going to be negative y, all this in parentheses, and power 5. Okay? Next, I'll solve 3 more questions and I will be done to make sure we understand well. So 6xy to power 4 over 11. All right. So how much is going to be my m here? My m is going to be 4, n is going to be 11, which means square root. So my n comes here, 11, and m is going to be 6xy to power 4. Okay, if I have 6ay to power 4, I can break this down. This is going to be equal 6 to power 4 x to power 4. Remember, we can distribute. We could not distribute in this case because 5x plus 4 is considered one term only. That's why, guys. It's considered one term only. Let me delete this one here. It looks like minus. There we go. Yeah, I just had a look and it looks like minus, and I'm thinking, what minus is that? No, I just underlined and it looks like minus. Let me underline this, take off this one also while I was explaining. Okay. So 6 to power 4, x to power 4, and y to power 4. And we are done. And here we could not distribute because it's one term. Real quick, how we separate terms? By multiplication. No, by addition. Okay? But here we have in parentheses. That's why the whole this thing is considered as a one term. Now here we have 6 times x times y, which means 6 to 4, x to 4, y to 4. Next one. Uh, 8 CD to power 2 over 11. Okay, what we're gonna do in this case, same way. So m is equal, n is equal, so m is equal 2, n is equal 11, which means 11 comes here, 8 c d squared. Or I usually write down right away, it's going to be every single term. You can distribute 8 squared, c squared, d squared. That's it. We know 8 squared is 64, therefore we are writing down 11, 64, c squared, d squared. In this case I didn't raise, you can do it if you want because it's too big of a number, 6 to power 4, I don't know how much it is. And I'm not going to punch numbers on calculator, but sometimes some answers accept 6 to power 4, sometimes they don't. So you can see if the first attempt doesn't accept, then second attempt put 6 raised to power 4 on calculator because it's enormously big number. Okay, and the last one. Nine AB to power 2/5. So this is equal. Okay, 5 comes here, 9 to power 2, 8 to power 2, b to power 2, which means radical 5, we get 81, a squared, b squared. Pay attention on one thing. Because degrees under radical is less than degree of radical, therefore we can't take out any term. Right? Okay, I'm done. I hope that helps you. And thank you for watching. I'll see you in the next video.